Yeah, this is maybe not the best one to miss for everybody, but oh well, I'll record and I'll put it up there, and you guys are here, and that's what's important. Um, I did put up on the on Canvas. Hopefully, you guys went and got it. The handout. We started looking at the one side yesterday. Let me share that with you right now. So before I do that, any questions before I get into where we left off? Any questions? No questions. Okay. So let me share this. All right, where are you? I think this is the one. All right. You guys see this? You guys see the thing? This is what we worked on yesterday, right? Does anybody see that? Please help me. Can you guys see that with all the blue writing on it? Anybody? Can you guys see it? Yes. Okay. Thanks, Alex. Oh my God. I was like, all right. So we finished this side yesterday. It was a review of what we'd already done. It was a review of seven. I think the 7.2. Right. So this is what I said we get into today. So the very first thing I want you guys to do, and this is probably good. We'll see if anyone else comes and join us. These first three problems here, A, B, C. Just take a minute and multiply those out, FOIL those out. Okay, so the A, B, C right there. You can see them on the screen. Please take a minute and FOIL those out. Is anybody on their phone? I'm always curious when I share my screen if you could really see it at all. Hopefully you can. I'm on the phone. I can see. Okay, thank you. So now I'll just do them. Just multiply those out. Should be nice. Let me see. 1, 2, 3, 4, 5. Funkadelic. Let me see. All right. Get out of the way. Oh. Welcome. Somebody just came in, so let me go ahead and start doing these with you guys. So I'm pretty sure we all remember how to do this. This is the nice way. If I have a problem to multiply and I can just multiply it out, I can see what's going on. So this very first one, right, it'll be 2x times 3x. I got to distribute. So again, the idea is I distribute the 2x through, and then I distribute the 5 through, right? That's the idea. Okay, so 2x times 3x is 6x squared. And then I get 2x times 7. And now the 5 gets a turn, right? Now I distribute the 5 through. 5 times 3x is 15x. And then 5 times 7 is 35. So then I get, at the end, 6x squared. Oops, why is there a double plus up there? Sorry, hold on. And there's another double plus, weird. All right, sorry. 6x squared plus 29x plus 35, right? Now I want you to notice something. Well, let's see, let's do this next one, and I want to point something out. So on this next one, same thing, same idea, right? 5x gets a turn. Whoa, I went a little too far up. And then -6 gets a turn. Wee-haw, right? Just distribute, or if you like FOIL, you can call it what you want to. 5x times 2x is 10x squared. Did I start the recording? Yes, I did, okay. 10x, whoops, where am I at? There I am. Squared, and then the 5x, let's do this one. 5x times -3 is -15x, right? -6 now gets a turn. -6 times 2, -12x. And then -6 times -3 plus 18. Okay, so hopefully everybody's gotten the same kind of answers here. 10x squared. Put the middle terms together, -27x plus 18. Now watch this. Before we do the last one, I want you to notice something. Look at the first one we did here. Let me put these here. The middle term, the middle terms, let's see if I can do this, come on. 14 and 15. What is 14 times 15? Does somebody do that for me? What is 14 times 15? If anybody read the rest of this, I'll actually tell you later, but just multiply those two in the middle. 14 times 15, what do you get? Anybody? Did anybody have a calculator? 14 times 15? Just do 14 times 15. I'm just trying to point something out. Can somebody do that for me and tell me what it is? 210. Okay. And just so you know, I don't know if some of you guys are concerned. That part A was done. I'm just coming back to it now to show you something interesting. So why are we doing these 3 problems in the first place? To get motivation for how to solve a problem, a factoring problem, where the first number is not 1. So I wanted to set up some problems here where the first number won't come out to be 1, so we can see if there's a pattern to it, and then we can make a process. We can factor these if we can see the pattern that happens. 14 times 15 is 210. And what's let me do this in a different color. What is 6 times 35? Oh my goodness, come on computer, catch up to me. What is 6 times 35? Somebody else is here. 6 times 35, 210. Isn't that, okay, now watch. Stay with me now. Stay with me. That's really weird, isn't it? Is that a little bit weird? A little bit weird? No? Okay. This one. What is 15 times 12? So again, just taking the 2 middle terms. What's 15 times 12? 180. And then what is the first times the last? What is 10 times 18? Oh my goodness. Just please, computer. Get it, go away. All right, let's try this again. 10 times 18. Oh, geez. What's 10 times 18? Also 180. Interesting, yes? A little tiny bit interesting? Okay, all right. So now we got a prediction. We got a prediction that we can make. Let's see if it happens for this one too. So when I multiply this one out, I get 7 times 5 is 35. 35x squared, right? Let me move you down. You're a little too high up there. Come on. Hello, computer. Oh my goodness. Okay. So that's 7 times 5 is 35x squared. 7x times 2 is 14x. And then the negative 3 gets a turn. Negative 3 times 5 is negative 15x. And then negative 3 times 2 is negative 6. No. There. Okay, so let's test this out. Before I even do the last step, watch. So what is 14 times 15? This one's kind of a repeat. 14 times 15, we already saw that that is 210. And what is 35 times 6? Negative 210, yeah, because it's negative. I like it, thank you. Negative 210. So that's just a little side note right now. It's just a little, you know, if I was just multiplying these and I just happened to notice, well, it seems like the two things in the middle always multiply to be the same things as the first and last numbers. And if you think about it, it makes sense. What goes into these two numbers are the parts that are from the first and last parts. The 5x times the 3 and the 6 times the 2x. They came from the same places. So it's not completely surprising that they would have some kind of similarity like this. By the way, this final answer here would be just for the multiplication, 35x squared. Oops, somebody's coming in. Where'd he go? 35x squared minus x minus 6. Okay. Boop. Now notice something. So what we just discovered is very important. It's going to be the basis of the process we use, right? But look at what's happening here. Are there factors of 18 that add to be 27? Just look at this one right here. Right? Let me remind you. Let me go up here. The way we did it when there was a 1 in front, we found factors of this number that added to be the middle number, correct? Yes? That was the whole idea with those kind of problems up there, was numbers that multiply by the last term and added to be the middle term. And I told you at the time that worked because the first number was a 1. This problem, is the first number a 1? No. And in fact, are there any factors of 18 that add to be 27? I'll let you think about it. Let's see, 18 and 1, that makes 19. 9 times 2, but when you add them, you get 11. 3 times 6, but when you add them, you get 9. Are there any factors of 18 that make 27? No, there aren't. So that same process won't work. Is this factorable though? Oh, here we go. Is this factorable? And yeah, I'm not going to go on until I get an answer. Is that factorable? This sounds like such an evil question. Somebody help me out. Somebody help me out. Out there, somebody out there in Zoom land. All of you guys, help me out. What is 11 times 17? Somebody have a calculator. What's 11 times 17? Can somebody do that for me? What is 11 times 17? Just somebody do that for me. Okay. You guys see Yangsha? I think it's, is that right? 11 times 17, 170, 187. Yeah, that's more like it. Yeah, okay. You get everybody with me? Even if you don't have a calculator, you know somebody has a calculator, and I'm agreeing with them, and I'm a math person. I have a math degree, so yes, it's 187. Is 187 factorable? Why is that kind of a silly question? Why is the answer easy? Is 187 factorable? This is not a hard question. How did we come up with 187? What did we do? Didn't we multiply 11 times 17 to make 187? Yes? So then if I ask you, is 187 factorable, shouldn't you go, all right, weirdo, yeah, of course it's freaking factorable. We just did 11 times 7. It's 11 times 17. It's factorable. Do you guys with me on that? Isn't that kind of silly? If I said multiply this and this is the result, you get factorable. It's like, well, yeah, it is, dude. We just multiplied things together to make it. Now look at what the hell we just did on part B. How did we get 10x squared minus 27x plus 18? Where did that come from? How did we get that? Didn't we multiply two things together? Right? You guys see what I'm saying? Where did this come from? What did we do to get here? Didn't we multiply those two things together, the 5x minus 6 and the 2x minus 3? Didn't we multiply those together? Yes, we did. So it's just as silly of a question then for me to ask you, is this factorable? You should go, duh, Jeff, of course it's factorable. We just multiplied those two things together. That's how it factors right there. Is this factorable? Is this guy factorable right here? Is this factorable?
Yes.
Yeah, because that's how we get there. We multiplied this times this. Okay. So my purpose for saying that is, obviously these are factorable. There must be a way that we can factor them. I've already shown you that the old way we had doesn't work anymore, and it's because these stupid numbers at the beginning, they didn't used to be there. The other day we had problems where it was just a 1 in front, right? There's just a 1, there was just a 1. Even if there wasn't a 1, we just get it out the way, get out of here. Now there's a 1, yeah. So when there's a 1 in front, things are much easier. When there isn't a 1 in front, things are freaky because now everything's been affected by those, right? Doesn't this 5 get multiplied by 3? Doesn't that 7 get multiplied by 2? Don't they mess with each other? So, okay. I know I'm throwing a lot kind of at you, but number one, I want you to realize when the first number is not a 1 and I can't take it out, I cannot use the same method for when the first number is a 1. It won't work. It can't work. Okay, that's one thing I want you to realize. Second thing I want you to realize is we've already discovered how to do these problems. I'm just going to point it out to you now. Okay. So for anybody who came in here a little late, do you see all this colorful stuff here? So we just multiplied those out. And then we realized before we combine these together, 15 times 12 is 180. And so is 10 times 18. In fact, over here, 14 times 15 is 210, and so is 6 times 35. That's some weird shit, and that happens every damn time. So watch how we can use that. So this I actually go over what I just said to you. We look at the first one, it's right here. So you can always reference this handout and read through it if you want to remind yourself about the idea, right? Look at this example. 12x squared plus 31x plus 20. The idea now is when the first number is not a 1, what do? I multiply 12. I multiply the first number. Oh, come on, Jeff. Come on, laptop. You can do it. I multiply 12. There we go. Times 20. Sure, I can work with that. All right. And again, you guys, you can do this. This is really freaky. I agree. But just to remind you guys up here, what did we notice? The first number times the last number is the same thing as the two middle numbers multiplied. So if I can find factors of this number times that number that add up to be the middle number, I can write something like this. I can work with it. So watch. 12 times 20 is 240, right? 12 times 20 is 240. I need factors of 240 that add to be 31. So I find things that add to be 31. 20 and 11 add to be 31, but 20 times 11 is 220. too low. And then I finally work my way to 16 and 15. They add to be 31, the middle number, and they multiply to be the same as 12 times 20. They multiply to be 240. All right, let me stop for a minute. This is really freaky shit, I know. So I told you yesterday and earlier today that the process for factoring something when the first number is not a 1 is going to be more complicated. It has to be. Because that first number can break up in a lot of different ways. So the process is going to have to be a little bit more difficult. It just has to be, to take that into account. All right. So then what we do is, see how we found 15 and 16? They multiply to be the same thing as 12 times 20, and they add to be the middle term. So I can break the middle term up. 31x is 15x plus 16x. Okay, so I'll tell you what. Let's do it. Let's do a fresh problem, because let's do this part A. I'm going to do it on the board, I think, because this gets a little bit crazy, I think, sometimes. I'm going to stop sharing. By the way, this handout is on the page. It's been on the page for a few days. It's on the Canvas page. All right, I'm going to stop sharing. Okay, let's see. So let's look at this one. Let me write up here for you guys. That's so weird. 3x squared plus 10x plus 8. All right, so now here's the idea. And I haven't really made a big deal out of this, but I should make a big deal out of this right now. Do you guys see how that's in the form ax squared plus bx plus c, right? That's in that form, where a is 3, b is 10, and c is 8. So sometimes this method is called the AC method, because the very first step, based on what we saw in the first part of this backside of this thing, the first step we do when the first number is not a 1 is we take a times c. 3 times 8, 24. We have to take this guy into account, because he's going to mess with shit when I multiply this answer back out. So if that was just a 1, I would find factors of 8 to add to be 10, and that wouldn't work. That's not a 1, so I find factors of 24 that add to be 10. Are there any factors of 24 that add to be 10? Damn it. Can't get high for this thing.
6 and 4.
Yes. Right? 6 times 4 makes 10. So now here's another new thing. And again, when the first number's a 1, everything kicks so much ass, because I just got to find the two numbers and then I write them in and I'm done. First number's not a 1, everything is a little bit worse. So I can't jump to the answer yet. What I do is this. We just said that 10x is 6x plus 4. We just figured that out, 6 and 4, right? So I'm going to write this, 3x squared. I'm going to rewrite 10x as plus 4x plus 6x. Do you guys see what I just did? This step here, when you do 3 times 8 and you get 24, find factors of that to add to be the middle and you break it up. That is the one way that the numbers that will make that middle term break up correctly. How many terms do I have now? How many terms do I have now?
4.
What do I do when I have 4 or more terms? What do I do when I have 4 or more terms? Good. Anybody remember? When I have 4 or more terms, what can I do?
Yes, group them.
I can group them. I group them, right? So the grouping will not work unless you use the numbers 6 and 4. How else can I make 10? 9 and 1, the grouping won't work. What about 8 and 2? The grouping won't work. The grouping won't work. Okay, so I've got to use the numbers that I get from doing 3 times 8 and breaking it up to make 10. That's it. I got to do that. We're going to do some more examples. And now it should be relatively nice. What comes out of these two?
X. Take
Yeah,
out
I could take an X out. You got to let go of all this other shit, right? Anytime you do a problem in mathematics, you get to a certain point, forget what the hell it came from. And I know we're going to do another example in a minute. We got to go back over how the hell I got all this shit. But right now, we're just looking at that right there. So what comes out of these two is an X. What comes out of these two? What comes out of these two? What comes out of these two right there?
Take 2 out.
Take a 2 out. How do I know I'm on the right track? How do I know I'm on the right track? No. All right. I mean, that's why that's true. But what I see in here that tells me I can do the next step? Are these the same? Do we need to do some grouping examples? Is that what's happening?
They're the same.
Yeah, why is that good? Why is that a good thing? Because you seem to believe it, Jeff. All right. Okay, maybe we should do some grouping examples. So let me say this, guys. Wherever the hell you are in homework right now, stop it. Do the current chapter. Catch up and hold old homework as you can. Algebra doesn't work unless you build a foundation to continue putting more stuff on, right? So if you're doing homework from the last chapter right now, you aren't building stuff to build on. You aren't putting a foundation down to build shit on, right? So we have to have a foundation of grouping to be able to do some of this other stuff. So yeah, the last step would be take a 3x plus 4 out, and then I'm left with x plus 2. All right, so now I know I need to go back and let's do some more grouping examples, because we'll never be able to do section 7.3 if we don't have grouping down. So let's do that. Where did I put my poor little, I don't know where that, oh, there it is. All right. So before we do any more of these, let's remember grouping. Okay. Just got some new markers, so hopefully let's see what happens. All right, so what about if I had let's see, plus BC2 A minus 5B. All right. That should work. All right. What is it about this problem, besides the fact that I just said we're going to be doing grouping? What is it about this problem that tells me to use grouping? Somebody knew this earlier. What is it about this problem that tells me to use the grouping method? Okay, how many terms are in this problem?
4 terms.
4 terms. And when do I use grouping? When there's 4 or more terms. Bam. So if you haven't written that note yet, write that note. It's a big ass note. That is the giveaway. When do I try grouping? When there's 4 or more terms. I like it. And then 7.2, 7.3 are about what do I do when there's 3 terms? So that's where we got to work towards. All right. So now that I know, I want to try grouping. And does everybody see there's no GCF? Right? There's nothing that goes into all of them, right? You guys see that? All right. Go ahead and try to finish that one up. Try to do the next couple steps. I'm going to close the curtains over there. All right. Oh, I left something out, didn't I? Damn it. Jeff. All right. So, oh, I see. Okay. Thank you, Kayla. I did leave one thing out. Of course I did. There's always the danger of making a problem up out of nowhere. So I don't know how far you've gotten. I don't see anybody yelling at me that you can't do it, but now you can. So let's see, what comes out of these two? This is what grouping means, right? I group the first 2, I group the last 2. What comes out of the first 2? What comes out of there? What number comes out?
2.
2. And how many letters come out? What letter, how many letters?
1A.
1A, I love it, right? He's got no B's, he's only got 1A. Okay, so 1A comes out. So 4 divided by 2 is 2. I had 2 A's, I took 1, I got 1 left. 10 divided by 2 is 5.
5. Or just A.
Well, the A is gone.
B.
It's just,
B. Only B.
right, because it took the A out.
Yes,
All right.
only B.
Now what comes out of those 2? What's the only thing that they have in common?
B.
Yeah, so I can take out a B. So he loses his B, so he's got just the 2A left. He loses one of his B, so he's just got 1 B left with their 5. How do I know I'm on the right track? How do I know I should be able to go further? Anybody, come on. What is it about this that tells me I'm on the right track?
Because
They're
you can
both
distribute.
2A.
What? All right, let me see. Kayla, what's up?
They're both 2A minus 5B.
Yeah. Right? I can't do the next step unless these are the same, because the next step is take out the thing that's the same. So you can very quickly see if you made a mistake, or maybe it's prime. If you get something here that's not the same there. But normally, if these are not the same, it's because you didn't take out enough somewhere. Right? Like somebody didn't take the 2 out, and they're like, well, that's not the same. but you just didn't take the 2 out. So very often it's like, guy, you forgot something. So you got to go back and make sure you take everything out.
I have a question.
Yes.
How I can know now you put B? How I can know I'm gonna put B and the second step I'm gonna put B with the 2A and 5B.
How do you know? Wait,
Yeah.
what? So, all right.
Yes, you understand what I mean?
Sort of, I guess.
Like
What comes out of both of these? What do both of these have? What do they have in common?
B.
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 So you take a B out because they both have it, so you can take the B back out. And then what do you get when you take the B out of this piece?
A.
Left 2A. And then this guy had 2 B's, so he's got how many? When you take one of them away, he's only got
5B.
Yeah.
Okay.
Okay, so again, I feel like probably quite a few of you guys haven't done section 7.1 yet.
Yes.
And 7.1 is huge because it is the foundation of a lot of the stuff we're going to do in chapter 7. That's why we put it in 7.1. It's the, here's somebody. Here, it's the, what do you call it? It's the thing that everything else is built on in a very real sense. Right, so maybe I should take another step back. All right, so let me finish this up. So I can take out 2 minus 5b, 2a minus 5b comes out, and then I'm left with 2a plus b. All right, so let you guys write that down, and then we'll take one more step back. We'll take a look at, and there's nothing wrong with this. It's just that if you don't ask me questions, I don't know where we are in terms of understanding. And if you haven't done the homework, then you don't have questions. And see, that doesn't work. Is that 55? It's a problem I made up completely on my own. It could be. You never know. I don't know, Veronica. I didn't get it from the book. But, Okay, so let's take a step back. Okay, I'm going to erase this. All right, let's come back to the first section. Let's see, 18. Okay, so if I want to factor this, I want to undistribute something. There was something that multiplied to make this and multiplied to make this. There's one thing, because it would have been something in front of something else right there. So I'm trying to figure out, the very first step is, what would have been out here? It must be the thing that both of them got. So when I distribute, I give whatever's here, I give it to both of the things in here, right? Are you guys with me on that? We have to be. So when I distribute, both of the things inside get the same thing. What does that mean? So if I did 5x times x minus 7, right? How do you do 5x times x minus 7? 5x times x, 5x times 7. So therefore, what do these both have? They both have a 5x. Right now, in that case, I know it because I saw it. I saw there was a 5x that was distributed. But if I didn't see that, I could see they both have a 5 and they both have an x. Bam, that's where they came from. That's why they both have a 5x, because it was what was distributed. It's what they both got. Okay. So what number do I see that's common to both the numbers? What number goes into both of these?
C. No, oh, sorry. Number.
What number goes into both 4 and 18? What number goes into 4 and 18?
2.
Yes. So there must have been a 2 that was distributed because they both have a 2. How many B's do they have in common? How many B's do they have in common? He's got
One.
2. Huh? Sorry?
1.
1. I like it. They both have 1B. I know he's got 2, but if I say they both have 1B. And of course, they both have how many C's in common?
2.
2. So really all I'm doing is the reverse of giving them both something. I am figuring out what they both must have gotten and taking it back. I am that asshole. Oh yeah, remember the thing I gave you? Can I have it back? Right? So I'm thinking, what did somebody give both of these guys? Let me take it back. So I can see from just looking at them what they have in common. That's why it's called greatest common factor. What's the biggest number that multiplies into both of them? So I can take it back out. So I had a 4 divided by 2 is 2. I had a B and I took it. And I had 2 C's and I took both of them. Oh shit, the first guy's got nothing left. Minus, had an 18 divided by 2 is 9. I had 2 B's, I took 1. Had 3 C's and I took 2. Let me stop there for a minute. How's everybody doing? Are you guys okay with this?
Yes.
So it's really,
Professor, can I ask something?
Yes.
2b squared is called common factor, right?
yes. And it is the greatest common factor.
Oh, greatest. Thank you.
Yeah, meaning if you just took out 1C, it would still work, but you wouldn't be done. Because you're supposed to take out 2 C's. You're supposed to take out the greatest thing that they have in common. I like it. How do you check this kind of problem? Well, you just multiply that back in and make sure that it comes out to be this. So it is just distribution in reverse.
So this is a GCF, right? Represent.
GCF,
Yeah.
greatest common factor. Yes, yes. GCF, greatest common factor. Let's try another. What about 18 a squared d plus, what do you got, Jeff? 27 a cubed d squared. So take this in stages. All right. What number goes into 18 and 27?
9.
9. How many A's can come out? Remember, the shortcut is you look at the lowest power.
A square.
A squared. And how many D's can come out?
D.
Just 1, 11. Oh, gather. And see how I put that a little bit back so that when I draw this, I put the answer for this here. So I don't forget them. 18 divided by 9 is 2. I had 2 A's, I took them. I had 1 D, I took it.
Yes.
Right? 27 divided by 9 is 3. I had 3 A's, I took 2, I got 1 left. I had 2 D's, I took 1, I got 1 left. How do you check it? You multiply it back in. Right? So it's really just what number goes in both the numbers. Each letter, you take out the smallest power that you see because that's how many they both have. If that's got a square and that's got a cube, he's got 3 A's, he's got 2. They both have 2 A's. Right? He's got more, but big deal. Good for him. He's only got 2. They both have 2 A's. So I can take it out because it must have been distributed in. So we're trying to do distribution in reverse, which is what GCF is. Okay, let's do another one. Let me write it up here. Let's see. What you got, Jeff? There we go. Yeah, I like it. Ooh, you can't even see it. All right, I'm going to erase this one. So there's three terms. Who cares? The method doesn't change. Look at the numbers. What's the biggest number that goes into all three of those? This might be a little bit tricky.
7.
Okay, let's go with 7. Let's go with 7. I love it. If you notice something, be quiet. We'll talk about it in a minute. Now look at each letter. X's. How many X's can you take out?
1x.
Yeah, only one, because that's the lowest power I see. Every one of them has 1x. I don't care that some of them have more. That's nice for them. What a great life for you. But this guy's only got 1. So that's the most I can take from everybody. So 1x. And then how many y's can I take out?
Y square.
Yeah, I could take it. He's got 5, he's got 3, but the lowest I see is 2. They all have 2 y's. So I could take out 2 y's. They all have 2 y's. So I can undistribute that. What's 42 divided by 7?
6.
And then I had 3 x's. I took 1. I've got 2 left. I had 5 y's. I took 2. I've got 3 left. Let me move that over a little bit. Do you see how I'm saying that? It's exactly how you can say it to yourself. I had 5 y's. I took 2 y's. So of course I've got 3 left. Please let that make sense. I had 3 x's. I took 1. So of course I've got 2 left. Plus, what's 14 divided by 7?
2.
2. 1x.
What was that? Yeah, x squared. I had 2 x's. I took 1 x. I had 3 y's. I took 2,
1 y.
1 y. Yeah, 28 divided by 7.
4.
4. I had 1x, took it. I had 2 y's, took it. How do I know
That's
I'm not
number
done?
4.
How do I know that I'm not done?
I don't know.
All right. Is there still something that comes out of these?
Yes, number 2.
There, that's how you know you're not done, because you haven't taken out the greatest common factor. You left something in.
Like CD. The CD, the first one.
It's not really like LCD. It's kind of like the reverse of that, but
I understand.
yeah.
Got
Because,
it.
so I could have taken a 14 out, believe it or not, but 14 is not really obvious that it goes into 42. But watch, if I take a 2 out, 2 times 7 is 14. If I take a 2 out now, there's 3 x squared y cubed, plus 2 divided by 2 is 1, and then negative 4 divided by 2 is 2. So I could have done that first, but it's not like LCD. It's like reducing fractions. If you reduce a fraction, do you sometimes have to reduce it a few times because you didn't think of a big enough number to divide by, right? I'm sure we've all done that before. You start to reduce a fraction, like, oh shit, I'm not done yet. I could have divided by a bigger number. Let me do it again. I know you've done that before. I know it. Same thing. We just didn't do the GCF. This is a common factor, but it's not the greatest common factor. Not 7, but 14 would have been the greatest common factor. So on this kind of problem, how do you know you're done when there's nothing else that comes out? There's no numbers that are the same. This guy's got no X's and Y's. I'm done now with that problem. Okay, so let's do one more problem and we'll call it a day. We're going to do a grouping problem now that maybe we got a better handle on GCF, I'm hoping. You got to do section 7.1. Whatever the hell you're doing, if you haven't done any of chapter 7 yet, Stop whatever you're doing and do 7-1. So you have some questions related to GCF because, like I said, everything else kind of builds on GCF to some degree. So a grouping problem is just 2 GCF problems in one. And when do I know when to do it? When there's 4 or more terms. So this is always exciting, making one of these out of nowhere. So let's see, 10 b squared minus, what do you got, Jeff? Sure, 5b. Let's see. Minus 1. So then we can do plus 2bc minus c. Sure. Let's keep it nice and straight, simple. Is there something that comes out of all 4 of these? Does GCF work? Is there something that comes out of all 4 of these terms? He's got no B and no number. These guys have no C's. So do you guys see how there's nothing that comes out of all 4? Is that all right? Do you guys see that? There's nothing that all 4 have in common. This guy doesn't even have a number, and these guys don't have C's. So they can't possibly have anything in common. Okay. And there's 4 terms, so I know I try grouping. So I've just created 2 GCF problems. There's one GCF problem, and there's the other one. Looking just at this, what comes out of these 2?
5.
5 and
B.
B. 10 divided by 5 is 2. Take a b from there. I got 1. 5b divided by 5b is 1. So it kind of makes sense. If distribution is multiplying something in, the process that's the opposite of that is dividing it out. Now what comes out of these 2?
C.
C. Kick ass plus C. Take a C, I got 2b. C divided by C is 1. How do I know this is going to work?
2B minus 1.
Yeah, now we're all on that shit. So if these 2 are not the same, more likely I've made a mistake, or it's possible it's prime, but it's more likely that I made a mistake if those 2 are not the same. Do not try to do the next step, because the next step is take out the thing that is the same. So if they're not the same, well, how the hell could you do that next step? But sometimes people find a way. They put some stuff down here and pray. So I can take a 2b minus 1 out. And what am I left with? 5b plus c. Right? There's 2b minus 1 times 5b. Bam. 2b minus 1 times c. Bam. So that is the answer for that. So that is a big time review of section 7.1. So just to remind you guys, whatever the hell you're doing in homework right now, stop and do section 7.1, and then go back and do old homework as you can. You got to keep up with the current stuff and then worry about older stuff whenever you get time. You have to. I want to show you something that I'm not done working on. Has everybody got that? I'm going to share something here. Let me pull it up here. I'm not quite done working on this, but I just want to show you my idea at the moment for the rest of the semester. Where is it? Where is it? Where is it? There it is. So you should see, do you guys see the Math 90 timeline homework? I'm going to say yes. Nobody's telling me.
Yes.
Thank you. All right. So remember, I don't even have 8 and 9 on the one that's up on the website. So here's 8 and 9, and I've also got the can everybody mute yourselves? Let me see. Okay. I've also got the quizzes sort of plotted out. Can you guys see that? So like the very first kind of like general quiz is going to be chapter 1 through 4 on the 12th. That's my plan. I'm going to finish this up today and then post it to Canvas and then let you guys know. But I'm pretty sure about what I've got up here. I just want to double check some timing stuff. Is everybody with me? So I'll finish that up and then I'll post it on Canvas and let you guys know. So you can have the last 2 chapters worth of homework and you can see what the plan is going forward, how many quizzes there are going to be and when they're going to be. So look at the next quiz to worry about is next Tuesday, I think, right? The 5th. The next Tuesday? Yes. Next Tuesday, we're going to have a quiz on 7-1 through 7-3. Oh, yeah. So tomorrow, we will finish up through 7-3 by tomorrow, for sure. All right. I need you guys to help me. I need you guys to do the homework so you have questions to ask. I need that. I can't guess at where we are, right? So today I could tell we needed to go back because I wasn't getting enough feedback on each step we were doing. So we have to understand 7-1, 7-2 before we can even try to do 7-3. So you got to help me out with that or else I can't help you. Okay. I think there's enough preaching at you. Sorry if I was a little preachy today, but you just got to do that. It just helps. It just makes things work. All right. Anybody have any questions? Need to hang out for a bit?
Excuse me,
Yeah.
I thought this paper is the first paper, but this one is you have 8 chapter 8 too.
Yep. So let
Yeah,
me
but
yeah,
where is,
I know. Let me show you. Hold on. So here, if you go, remember this website?
yeah,
If you look at the homework,
yes,
can you see the homework now?
yes. Okay,
Chapter 8 and 9 homework will be given out later. Yes? Do you see that?
yes,
Okay. So I'm going to finally give it to you. So you knew it was coming. You knew that the semester didn't end at chapter 7. I just didn't want to make this a 2-sided thing. And I figured I'd have to update the schedule anyway. So I figured I'd give it later. So hopefully later today, I'll have it finished to give to you guys.
okay, thank you.
You're welcome. All right. Any other questions? Anybody else
No,
have
thank you.
questions, or you just want to get the hell away from crazy math, dude? I understand. All right.
Bye.
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 See you guys.